Hello. So this is the Unit 1 test review. So we'll go over the different topics. So the first topic is going to be square roots. Let's take a look at the first question. So it says, Elena needs to cut a square piece of wood with an area of 169 square inches. So area means, look at all these boxes, and there's 169 square inches, right? Or square boxes. So in order to find one side, you do not divide by 4. You need to figure out the square root, because whatever this side is times this side here, that's going to equal 169. So if you put the square root of 169 in your calculator, that's going to give you 13. Okay, so the question is, what would the side length of the table be? It would be 13 inches. Okay, so let's take a look at question number 2. So the next question says, which of the following irrational numbers would not lie, keyword not lie, between 10 and 11 on a number line? So we have 10, about 10.2 here. This one is about 10.5. This one is 10.95. And this one is 11.2. So remember, if you have between 10 and 11, that's going to be more than 10, less than 11. So it's 10 with some change. But the key word here is not lie. So not lie, that one lies, so that's a no. This one lies, no, no. The only one that would work would be D. Okay, so the next question is, between which two integers is the square root of 20 located? So if we put the square root of 20 in our calculator, we would get something around a 4.47. So this is more, remember when we get back to the money reference, right? So this is $4 and some change. So you're spending at least $4, right? You have $4 and some coins, but you're still under $5. So this would be between 4 and 5. Okay. So now we're going to learn about rational versus irrational. So remember, rational can be anything with negatives, positives, whole numbers, fractions. Okay, and then the decimals are repeating or terminating. So let's take a look. Kelly is learning about rational and irrational numbers. What conclusion can she draw about 0.0120012000012? So it's irrational because it repeats. Well, no. Only rational numbers repeat. So regardless, it's a false statement. So this one's a no. It's irrational because it neither repeats or terminates. Looks good, but let's read through the rest. It's rational because it terminates. It does not terminate. Oop. Okay, and it's rational because it repeats. Okay, so this one is where people get confused, right? Whether it repeats or does not repeat. So there is a pattern. However, the pattern is not repeating. It have to be like 0, 1, 2, 0, 1, 2, 0, 1, 2, right? But the numbers are not repeating. There is a pattern, but it's not repeating pattern. So I can eliminate these two. So your answer is B. So you can see it does not repeat, right? There is a pattern, but it's not a repeating pattern. And you can see by the ... is not terminate. So let's take a look at the next one. So right here, if we put this in our calculator, you're going to get a decimal, which means it's a non-perfect square. Okay, all non-perfect squares are irrational. There is an exception. It could be if you multiply two irrational numbers. But always double check in your calculator. Why is this? Hold on one second. I don't know why it's freezing. Give me a second, guys. Okay, so for the answer of this one, it wants to know if it's irrational or rational. This one is irrational. Okay. The next one is a classification. So this kind of also goes into our real number system we're going to go into. So if you put this in your calculator, you're going to get 14. So remember the order. So we have natural. Oh, that looks weird. Hold on. Whole. And then integer. And then rational. And then all of them are real. And there's also over here, there's irrational. So whether it's irrational or rational, they're all real. This right here is a natural number. I could count to it like a child. So it's going to have natural and all of the subsets below up to real. So the answer is natural, whole, irrational, rational, and real. Okay. So as you go along too, I would say to make sure that you're looking over here, decide if it's a strength, you need more practice, or a weakness. That way you can determine what you need to study, okay? So let's take a look at the real number system over here. So we're going to think of this over here, right, as we move forward. So we have natural, and then whole, and then integers, rational, and then real. Oop. Oh my goodness. If you can't read it, you should know what it represents. Okay, so the first question says, which is true about the following, about subsets of the real numbers? So you remember, you want to take your subset and look at everything above. Okay, So the first one says the rational numbers are a subset of irrational. So if I'll take a look at rational and irrational, they're not even in the same division. So that one is going to be not working. Okay, let's take a look at the next one. The next one says the whole numbers are a subset of integers. So remember, you can take what you see and it falls under everything above. So I have whole, integer, rational, and real. So if it's whole, it's also integer, it's also rational, it's also real. So the question asks, the whole numbers are subsets of integers. Yes, that's true because this lands below this. Okay, so let's take a look for the next one. The integers are a subset of irrational numbers. So for that one, it's not, because if you take a look, you can see that integers and irrational are two completely different parts. So that one I can also eliminate. Whole numbers are a subset of natural numbers. So this is where the above part comes in. So if I have a whole, it also represents an integer, rational, and real. It does not also include natural numbers. So although it may look like it is, right, because they're under the same block, it actually isn't, because it's not a subset. You only look at the numbers above it, okay? Let's take a look at one over here. What type of numbers can be included in the set of irrational numbers? Okay, so one type is non-terminating and non-repeating decimals. So an example would be 0.31311, right? There is a pattern, but it's actually not repeating. Another example would be just pi. So it's 3.14, blah, 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 right? The second one is non-perfect squares. Okay, so an example of that one would be square root of 10. Okay, last question. Name the subsets for rational numbers. All right, so we want to take a look at everything below rational numbers, okay? Because rational numbers are going to include integers, whole numbers, and natural numbers, okay? If it's a natural number like 1, 2, 3, 4, that's also going to be a rational number, right? That's also included up in here. If we have a whole like 0, also in here. Integers like -3, also in there, okay? So all of these, the integers, whole, and natural, is going to be included. Sorry guys, the other one, it didn't flip. So I'm using a different program than I normally do, and it is glitchy. Oh my goodness. Okay. So remember, you want to go back to rate yourself and determine if you're a smiley face, you're unsure, or you're sad, okay? And if you need anything, always feel free to send me an email, okay? So we want to figure out which of the following numbers is the smallest, okay? So this right here is going to go back 3 spaces. 1, 2, 2, 3. Okay? So this is 0.0054. This one's going to go back 6 spaces. So 1, 2, 3, 4, 5, 6. So that's 1, 2, 3, 4, 5. Okay, so 0.123 4 5 zeros 4 7 9. Okay, this one goes back 5. So I have it's the other way. 1 point. So 1, 2, 3, 4, 5. So 4 zeros. So 0.123412. And then this one is 8.458. 1, 2, 3, 4. Okay, so you have 0.00. I promise this is frustrating me more than you. Okay, so you take a look. And I like to do looking at the first one. So all the whole numbers are 0. Okay. And then from there, we're going to look at the tens place. So the first decimal, we have a 0, 0, 0, 0. I have 1 0, another 0, another 0, another 0. So far, we've gone through the 100th place, or about 2 numbers after the decimal. Okay. Now, we're going to compare the next one. I have a 5. A 0, a 0, and a 0. Okay, so smallest, right? 5 is not smaller than 0, 0, 0. So this right here is going to be eliminated. Okay, so let's go ahead and cross out the next number and we'll keep going on. Okay, so to take a look at the next number. We don't even have to worry about the first one. So I have 3 crossed out on each one. I do a different color so it stands out a little better. So I have 0, 8, and 0. We're looking for the least number. 8 is not going to be the least. So cross that out. Okay. Now I can eliminate the zeros. 1, 2, 3. It would have been the other 0, not that one. La da da. Fix, fix, fix. Okay, now that that's fixed, we can move on to the next one. So we get a different color. We'll do green. So next is 0 and a 1. So we're looking for the smaller number. So between 0 and 1, I would say the 0 is a smaller number, so I can eliminate C. So that gives me my final answer of B. Okay. Let's take a look at the next one. So it says, write the following numbers in scientific notation. So remember, you want one number after the decimal. So you're going to count your bunny hops. 1, 2, 3, 4, 5, 6, 7. 7 bunny hops. So the decimal lands between the 1 and the 5. And remember, if it's a number bigger than 1, it's a positive exponent. A number less than 1, negative exponent. This is definitely bigger than 1. So we're going to do to the power of 7. And then this one is definitely less than 1, so it's going to have a negative exponent. So remember, you only want one number in front of the decimal. So 1, 2, 3, 4, 5, 6, 7. Okay, so 2.13 times 10, it's less than 1, so negative 7. Okay, so this is greater than 1, so it's a positive exponent. And the other one is less than 1, so it's going to be a negative exponent. Okay, so let's take a look at the third one for the scientific notation. So this one is saying that it's given in given in scientific form. So now we need to transition it over to standard. So 3.4, and then this is a positive number, so we're going to go to the right. So 1, 2, 3, 4. So your decimal is going to end right here, and then you're going to replace those empty slots with zeros. So you're going to get 3, 4, and then 3 zeros after, which gives you 34,000. Okay, this one is negative, so you're going to be going to the left. So we have 5.9, and I'm going to have it go to the left. 1, 2, 3. So the decimal is right here. And if you need to put a number in the front, you're going to put a 0. So it's going to be 0 point, fill in those with zeros, 0, 5, 9. So this is the answer for B. And remember, once you're done with that section, you want to go through and determine if that was a strength, if you think you need more practice, or if that's something that's your weakness. Okay? Let's take a look at ordering real numbers. So with a lot of these, you do not want to do these in your head, right? You're going to want to put them into a calculator and get an actual estimate. You do want to keep track of which number is what in the calculator, so I do suggest writing it on the paper so you don't lose track. Okay, so it says to do the following numbers ascending order. So remember ascending like a plane. So if it's going up in the air, right, it's going from the least amount of feet up to the greatest amount. So smallest to biggest. So let's take a look. So if I put these in my calculator, this is about 7.3. This one is 0.73. This one is 9.4. Actually, let me kind of separate these a little bit better, just so it's a little bit clearer. So this one right here is 7.3. This one right here is 0.73. This one right here is 9.4. This one right here is just match it, 0.942. And then the last one is a decimal, and that gives us 0.88. And it's a repeating number, so we can draw the bar above it. Okay, so remember, ascending goes from least to greatest. So small to big. So first things first, you want to look at the whole numbers, okay? So I'm going to put a star below which has a whole number of 0. So this starts off as 0, this starts off as 0, this starts off as 0. So one of those is going to be the least. Okay? So let's take a look. So I have 0.7, 0.9, and 0.8. So the least one is going to have the 7. So we know that's going to be this one here. And we'll double check it matches. And then 8, and then 9. So for those 3 stars, that matches the 3 in order here. And then we could take a look left. I'll put a little smiley face below the other ones. we just go back to the whole numbers. So we're comparing the whole number of 7. So 3 squared root of 6 would be next. And then the last one, the whole number is 9.4. So that would be 3 pi. So your answer is B. Okay. Now descending, right? Think of a plane descending. It's going to go from greatest to the least. So this one's a little bit different because it's not like basically like a word bank here and you rearrange them. This gives you 3 separate options and you have to determine which one is going in the correct order, okay? So square root of 45 is about 6.7 and this is negative 5.5. This is about 6.3 and this is negative 6. So we're going from a whole number to a negative back to a whole. No, that does not work. We can't go from negative positive to negative. So that's not going from greatest to least. This one is 5.6, 5.5, negative 3.5, and negative 3.2. So remember, the larger the number here, right, the smaller it is. The larger, let me do this in a different color. The larger negative is smaller. Okay, so this one also will not work. So let's double check the last one then. So square root of 75 is 8.7. Okay, that's a big number. Then lowers to 8.5. Then the next number is negative 4. And then the last number is negative 4.5. So negative 4.5 is going to be smaller. So that works with this descending order that it asks for. So your answer is C. So the very last question gives you the numbers. It is not multiple choice. You do have to put it in order yourself. So let's take a look right here. So remember, you could put this in your calculator as 15.2. Remember, percent is out of 100%, so divided by 100. That you would just put in as is. That's just repeating 5. So this one gives you 0.152. Okay, this one right here is 3.5. This one right here is just the 15. Remember, 3.5 with the bar above means the 5 is repeating. And we'll see if we need to spread that out. So looking at whole numbers first, this one has no whole numbers, so we can represent nothing with 0. So ascending means it's going up. So it's going to be least to greatest. So this would be the least number. Taking a look at the next ones, I have 3.5 and 3.555. So this is 3.5, 5, and so on. Okay, there's nothing after. We can represent nothing with 0. So if we take a look at the first number, they're the same. Second number, the 0 or nothing is essentially smaller than 5. So this would be the second. And this one's coming in for a close third. Okay, that makes 15 the last one. So we want to write it in order based on what you see up here. So you want to do this one, and then this one, and then this one, and then this one last, okay? So we're going to write it as 15.2%, and then 7 over 2, and then 3.5 repeating, and then 15. Okay, so that's going to be the ascending order for that. Once again, make sure you take a look at your strength. If you have this as an area of strength, an area that needs more practice, or an area of weakness, okay?